another episode of Sci-Connect. I am Teacher Nell, your science teacher for today. Are you now ready to learn? Let's start!
You have already learned the laws of motion, faults, earthquakes, asteroids, typhoons, and the particle nature of matter. Science is not possible without the very nature of what makes up everything surrounding us, including us, atoms. It's time to study all about the atoms. The most essential learning competency for this lesson is to determine the number of protons, neutrons, and electrons in a particular atom. Your specific objectives are the following. Name the early scientists involved in the development of atomic theory. State Dalton's atomic theory and compare Dalton's atomic model from J.J. Thomson's raisin braid model. The following are the terms used to help us understand about this lesson. Atom is the smallest particle of an element. Discontinuous, indestructible, or indivisible. Electron, the negatively charged particle of an atom. Indivisible, uncuttable, or cannot be divided. Molecule is a group of atoms banded together. Nucleus is the center of an atom. Phase transformation is a change in phase of matter. Example, change in phase from solid phase to liquid phase. Proton, the positively charged particle of an atom. Before we start with our lesson, let us determine your prior knowledge by answering the 5 questions as your pre-test about the atom. Directions. Choose the letter of the best answer. Write your answer in your answer sheet. Number 1. Who was the scientist who described that the atoms of one element have the same number of protons? A. John Dalton, B. Niels Bohr, C. Henry Moseley, D. Joseph John Thomson. Which among the options below correctly match the name of the scientist and his or their contribution in the development of atomic theory? A. John Dalton, the atom is like a planet. B. Joseph John Thomson, an atom is a positive ball of electricity with negative poles embedded. C. John Dalton, the atom is like a solar system. D. Niels Bohr, matter is composed of tiny and divisible particles called atoms. Number 3. When copper was exposed to air that contains oxygen and heated, it was found out that the product form has a copper to oxygen mass ratio. The experiment was repeated several times and gave the same result. Which assumption in Dalton's atomic theory states on the collection of the same kinds of atoms before and after reaction? A. According to Dalton, atoms remain unchanged during chemical reaction. That's why the same product, copper oxygen, was collected after repeating the experiment for several times because the same material was used before and during the chemical reaction. Letter B. According to Dalton, atoms of different elements have the same properties. That's why the same product or copper oxygen was collected after repeating the experiment for several times because the same material was used before and during the chemical reaction. Letter C. According to Dalton, atoms of one element have different properties. That's why the same product or copper oxygen was collected after repeating the experiment for several times because the same material was used before and during the chemical reaction. Letter G. According to Dalton, atoms combine in ratios of small whole numbers when they form compounds. That's why the same product or copper oxygen was collected after repeating the experiment for several times because the same material was used before and during the chemical reaction. Consider this atom. Question for number 4. Which assumption in Dalton's atomic theory describes the nature of these atoms? Justify. Letter A. According to John Dalton, atoms are indivisible, meaning they are indestructible. Therefore, they remain unchanged during the chemical reaction. Letter B. According to John Dalton, atoms of different elements have different properties. Since both are atoms of the element hydrogen, therefore, these two atoms have different size, mass, and shape. Letter C. According to John Dalton, all atoms of a given element have the same properties. Since both are atoms of the element hydrogen, therefore, these two atoms have the same size, mass, and shape. Letter D. According to John Dalton, atoms combine in ratios of small whole numbers to form compounds. Therefore, a 2:1 ratio of hydrogen to hydrogen combines to form a molecule of hydrogen. Number 5. Which among the diagrams below shows the correct comparison of the atomic model of Dalton-Thomson? Is it A? Is it B? Is it C? Or is it D? This time, let us start our lesson by performing the first activity. Activity 1, entitled Think, Pair, Share. Directions: connect a line from the name of the scientist to his or their contribution in the discovery of the atom. Write your answer in your notebook. Column A and column B. We have column A, the name of the scientists, and the picture. We have A. Ernest Rutherford. We have B. Joseph John Thomson. For the column B, we have matter is discontinuous or indestructible. It is made up of tiny and indivisible particles called atoms. The atom is like a solar system. Its mass is concentrated in the nucleus. Electrons are particles moving around the nucleus in circular orbits. We have again column A and column B. For column A, we have the picture of Henry Moseley. Another picture, Niels Bohr. Another picture of John Dalton. And another picture of Leucippus and Democritus. For column B, we have atoms are indivisible and indestructible. They do not change during chemical reaction. Atoms of elements have the same properties. Atoms of different elements have different properties. The atom is mostly empty space. Its mass is concentrated in the nucleus. All atoms of one element have the same number of protons. And an atom is a positive ball of electricity with negative balls embedded. Let us explore another activity. Activity number 2. Entitled Comic Strip Review. Now, let's get into the details. This time, your task is to analyze what is being shared by Colas and Lucky in the story. After that, Try to reflect on the questions found at the end of the comic strip and share your idea on Dalton's atomic theory. In answering the questions, always refer your answers based on your understanding on Dalton's atomic theory. Write your answers in activity. Kulas, would you mind telling me about Juan? He's the talk of the town today. Who is this guy, huh? I need to know. Wow, Lucky, I thought you're one of those happy-go-lucky guys, but you amaze me with your enthusiasm and curiosity. Hang on there. I'll change clothes first and I'll tell you. John Dalton, my friend, is his real name. For him, matter is composed of tiny, indivisible, and indestructible particles called atoms. All atoms of a given element have the same properties. Atoms cannot be created nor destroyed. They remain unchanged during chemical reaction. Atoms combine in ratios of small whole number when they form compounds. Come again? What happened when atoms form compounds? During chemical reaction, atoms combine in ratios of small whole numbers such as 1:1, 1:2 to form compounds. My tummy is full as well as my brain. Thanks, Kulas, it's time for fresh water. Your tummy is full of atoms of grasses that you have eaten. Aren't you tired of eating? Oh no, this will always be my favorite. I wonder what kind of atoms are present in water. Guide questions. Number 1. Enumerate the 4 assumptions, statements of Dalton's atomic theory. Consider the molecules of oxygen. 2a. How many atoms does an element oxygen have? Which assumption in Dalton's atomic theory does this example apply? 3a. Are the atoms of oxygen the same in size, shape, and texture? B. Why do you say so? Consider the molecules of water. 4a. Are the atoms of oxygen and hydrogen alike? B. Why? C. What assumption gave you this idea? Number 5. When atoms of oxygen and hydrogen combine, will the new product also contain the atom or atoms of oxygen and hydrogen? Justify. Number 6. Which assumption in Dalton's atomic theory is involved in the formation of compound? Let's explore another activity. Number 3. Entitled Dalton versus Thomson. Let's go further. In this task, you will make a representation of the 2 atomic models, Dalton's atomic model and Thomson's atomic model. From their atomic models, you will be required to answer the guide questions given to you. Enjoy your exploration. Materials: 2 coupon bands, long, scissor, 1 red colored paper, 1 yellow colored paper, mug, pencil, paste or glue, and a roller. Procedure for Dalton's atomic model. Number 1. Position the mug at the top of the red colored paper with the mouth touching surface. Using a pencil, trace the mouth of the mug at the colored paper and cut it. Number 2. Paste the cutout at the center of the coupon band. Below the figure, label it Dalton's atomic model. Now you have already made an atomic model based on Dalton's idea. For Thomson's atomic model, number 3, make another cutout by following step number 1. Number 4, get the remaining bond paper and paste the cutout into it. Number 5, trace a 25 centavo coin at the top of yellow manila paper and cut it. Make 5 cutouts and mark a heavy horizontal line on each cutout. Your figure should look like this one. Number 6, spread the yellow cutouts horizontally at the top of the red circle. Make sure to give enough spaces in between them. Paste it. Number 7, fasten the red circle at the top of a bond paper. Number 8, below it write Thomson's atomic model. Guide questions. Number 1, describe your model of the atom according to John Dalton. Number 2, describe your model of the atom according to Joseph John Thomson. Number 3, how is Dalton's atomic model similar to Thomson's atomic model? Number 4, how is Dalton's atomic model different from Thomson's atomic model? Number 5, compare Dalton's atomic model from Thomson's atomic model. The first activity unfolded how atoms came about, how it looks like, its parts, the particles found in it, and the atomists behind the different atomic models. Here is a table showing the early scientists and their contribution in the development of the atomic theory. The second activity highlights the assumptions made by John Dalton on his idea on atom. Dalton's atomic theory are as follows. Matter is composed of tiny, indivisible, and indestructible particles called atoms. All atoms of a given element have the same properties, and atoms of different elements have different properties. Atoms cannot be created nor destroyed. They remain unchanged during chemical reaction. Atoms combine in ratios of small whole numbers when they form. The third activity compares the different ideas of Dalton and Thomson about an atom. It was described through their atomic models. The diagram below shows how the two models are alike and how they are different. An atom is a solid, empty sphere. An atom is a solid sphere of positively charged with negatively charged particles embedded in it. The idea of atoms started from the early scientists to the modern atomists. Based on Dalton's atomic theory, all things, whether it is solid, liquid, or gas, is composed of atoms. Dalton pictured atoms and matter as small and cannot be divided or uncuttable. In activity number 2, you were asked if the two atoms of oxygen are alike in size, shape, and texture. The answer is yes, because it follows the assumption of Dalton that atoms of one element have the same properties. Likewise, the atoms of oxygen and hydrogen are different in their properties because they are different atoms of different elements. When atoms of oxygen and hydrogen combine, one product that will be formed is water. Water, as a result of the chemical reaction between atoms of oxygen and hydrogen, retains the atoms of oxygen and hydrogen in it. Water contains one atom of oxygen and two atoms of hydrogen. This is what is meant by Dalton when he said that atoms remain unchanged during chemical reaction. Water is a compound because it is a combination of two kinds of elements or atoms. The chemical formula of water is written as H2O1 or simply as H2O. As you can see, there are two elements of hydrogen and one atom of oxygen in compound or molecule of water. The numbers 2 and 1 are the small whole numbers mentioned by Dalton in the formation of compounds. Let's find out some more to enlighten your ideas on atomic structure. Try to ponder on this. You can do it. When copper was exposed to air and heated, it was found out that the black compound formed has a copper to oxygen mass ratio of 4:1. The experiment was repeated several times and gave the same results. Which assumptions in Dalton's atomic theory explains this phenomenon? To strengthen your idea or your knowledge about this lesson, let's perform the next activity by answering the question. Write your answer in your activity notebook. Question: provide examples where atoms and its application is existing. Discuss briefly and why. Now, let us have the post-tests. Directions: choose the letter of the best answer. Write your answer in your answer sheet. 1. Which among the options below correctly match the name of the scientist and his or their contribution in the development of atomic theory? A. John Dalton, the atom is like a solar system. B. Joseph John Thomson, an atom is a positive ball of electricity with negative balls embedded. John Dalton, the atom is like a planet. D. Niels Bohr, matter is composed of tiny indivisible particles called atoms. Number 2. Who was the scientist who described that the atoms of one element have the same number of protons? A. John Dalton. B. Niels Bohr. C. Henry Moseley. D. Joseph John Thomson. Number 3. When copper was exposed to air that contains oxygen and heated, it was found out that the product formed has a copper to oxygen mass ratio. The experiment was repeated several times and gave the same result. Which assumption in Dalton's atomic theory states on the collection of the same kinds of atoms before and after reaction? A. According to Dalton, atoms remain unchanged during chemical reaction. That's why the same product, copper-oxygen, was collected after repeating the experiment for several times, because the same material was used before and during the chemical reaction. Letter B. According to Dalton, atoms of different elements have the same properties. That's why the same product, copper-oxygen, was collected after repeating the experiment for several times, because the same material was used before and during the chemical reaction. Letter C. According to Dalton, atoms of one element have different properties. That's why the same product, copper-oxygen, was collected after repeating the experiment for several times, because the same material was used before and during the chemical reaction. Letter D. According to Dalton, atoms combine in ratios of small whole numbers when they form compounds. That's why the same product, copper-oxygen, was collected after repeating the experiment for several times, because the same material was used before and during the chemical reaction. Number 4. Which among the diagrams below shows the correct comparison of the atomic model of Dalton and Thomson? Letter A, letter B, letter C, and letter D. Consider this atom. For question number 5, which assumption in Dalton's atomic theory describes the nature of these atoms? Justify. A. According to John Dalton, atoms are indivisible, meaning they are indestructible, therefore they remain unchanged during chemical reaction. Letter B. According to John Dalton, atoms of different elements have different properties since both are atoms of the element hydrogen. Therefore, these two atoms have different size, mass, and shape. Letter C, according to John Dalton, all atoms of a given element have the same properties. Since both are atoms of the element hydrogen, therefore, these two atoms have the same size, mass, and shape. Letter D, according to John Dalton, atoms combine ratios of small whole numbers to form compounds. Therefore, a 2:1 ratio of hydrogen to hydrogen combines to form a molecule of hydrogen.
Congratulations, learners, for finishing the visual lesson. I hope you enjoyed learning with me today. Remember, learning is fun with Sci-Connect.